Hello again. Welcome to the last week's next lecture. Again, as I told you during the mobile apps testing lecture, in response to my pinging on the forum about what you would like to have, a few of you had also requested for a module on performance testing. So here is a module that caters to that. This particular lecture doesn't do only performance testing because either you do it by opening a tool, some of them are proprietary and cater to a web application, or you give an overview. If I give an overview, then it won't be enough for one lecture. But if I open a tool, then that goes out of the focus of this course, which was focusing on algorithms. So what I decided I'll do is that I'll give you an overview of all popular non-functional system testing techniques, and performance testing will come as a list in this set of techniques. So that's what I thought I will cover. Next module I'll do regression testing. So here is an overview of what we are going to do in this lecture. I'll give you a taxonomy of system testing that is typically done, and we will focus on, as I told you, non-functional system testing, and as requested I'll also look into a little more details about performance testing by giving you tools that are open source, proprietary, what are the goals to measure, and so on. So if you remember, I had shown you this V model long ago when we began in the first week in the course. So on the left hand side of the V model is what we have, the normal software development life cycle. We do requirements, architecture and design, coding, low level design, coding, and then we do testing. But when it comes to focused testing, we usually expand the V model into its right arm, which tells you what is the kind of testing that is done. Right here at the bottom, along with coding, I do unit testing in an agile methodology typically done by the developer, after which I do integration testing. Software modules are integrated. Software is integrated with hardware, database, and tested. Then we do system level testing, where everything is put together with the entire working system and tested. Finally, acceptance testing. This model we had looked at long ago. What did we focus on in the course till the past few weeks? They were here and here. Coding, unit testing, and integration testing. What has been the focus of this week and in the past when we did web applications and object-oriented testing? That's been system level testing. Today again, we'll look at system level testing, but not focus on functional system level testing. Instead, focus on what is called non-functional system level testing. Again, in the first week in my introductory lectures, I had introduced you to two kinds of testing, several dichotomies in testing, and one of it was functional and non-functional. So here is the category that we did right in the first week that we are recapping again. There are two categories of system level testing that we would like to recap. One is called functional testing, which we have looked out for majority of the course. Basically tests if the software meets its requirements. White box, black box, anyway. The next is called non-functional testing, which basically tests the software to check if it meets various quality attributes. As per an ISO standard, there are 64 different quality attributes, most of them ending with the word LITY or TY. So many organizations popularly abbreviate them and call them as ILITs, which is what non-functional testing focuses on. Non-functional testing typically begins only at the system level. We don't really do non-functional testing here at coding and unit testing or at integration testing, but the work for non-functional testing, as we saw in the V model, begins along with requirements, architecture and design. Typically, it is the architecture that caters to quality parameters. The work in terms of what to test for, inputs for test case design, they get readied here. Actual testing happens here. So our focus is on non-functional testing. So here is the same dichotomy which expands out into non-functional tests. So for our classification, there are two kinds of system tests, functional system tests and non-functional system tests. There are several different varieties of non-functional system tests. I have chosen to put a few popular among them, and I should also explicitly tell you that I have left out a good number of them. So this by no means is an exhaustive listing of all the non-functional tests. What we will be doing in this lecture is sort of go through them one after the other. So performance I'll reserve for the end. We'll begin with interoperability, follow it with a brief overview on security and reliability. To reiterate what I told you in the context of mobile apps testing, these two are very involved areas. This course, what we do is by no means even a cursory introduction to these elaborate testing fields. We look at what is scalability, testing for scalability. Regression testing, I'll do a separate half-an-hour module because again there was a request for that. Today I'll also tell you about documentation and regulatory testing. So system tests, two categories, functional, non-functional. Our focus today is non-functional tests, and specifically we'll look at all this except for regression testing, which we'll do in a separate module. And security and reliability need in-depth analysis, which we will not be able to do in the course due to lack of time. So the rest I'll tell you. We begin with interoperability testing. So what does the word interoperability tell you or remind you of? It says something should work with the other across platforms, across operating systems, across languages. So that's what interoperability testing does. It determines whether a system can operate or interoperate along with other third-party products. Suppose I say that I have a recording software and it should be able to operate with any kind of camera on any system. It could be installed for a Mac system, for a Windows system, or for a Linux system. But whatever it is, let's say there's an inbuilt camera, there's an externally fixed camera, there's a USB camera port. Whatever it is, my recording software should be able to pick up the data from the camera and record. So it should be interoperable along with a third-party software or a hardware component. That's what interoperability testing does for. A particular wing of interoperability testing is what is called compatibility testing. What does compatibility testing do? It involves checking for compatibility with different operating systems, different browsers, different database servers, and so on. When we did the module on mobile apps testing, I had spoken to you a bit about this. So when I say I have an app, a good enough app, I make it amenable to run on an Android OS or in an iOS and so on. Similarly, I have a piece of something, let's say a tool like JUnit. Will it run on a Windows machine? Will it run on a Linux machine? That's what compatibility testing does. Compatibility testing also checks for forward and backward compatibility. Let me give you an example for that. Let's say you have Microsoft Office software, which has a Microsoft Office tool suite, PowerPoint, Microsoft Office Word, Excel, Outlook, so many other things, right? And they keep releasing newer and newer versions. So now let's say you have an Office Word document that you opened with an older version, let's say 2007, it should be compatible with a newer version, whichever, in the sense that if I had developed a document with an older version, I should be able to open and edit it in a newer version. That is what is called forward compatibility. Backward compatibility means if something was developed in a later version, then I should be able to at least open it in a previous version. May not be able to edit it if it uses newer features of the later version, but I should at least be able to open it and view it. So interoperability also deals with checking for compatibility. Sometimes you will get messages, especially when you're working with some websites operated by governments or banks, saying that this is compatible only with the following browsers and the following versions of these browsers, which means what? It has features that suit only these browsers and these versions. It is not compatible with other browsers and their versions that are not specified in the list. So this is another important non-functional testing that people do at a system level testing for a software or a system. So the next is security testing. Just to repeat at the cost of being repetitive, I tell you that we are only scratching the surface. This is a very involved area. Feel free to browse through other courses or books that talk about it. I'm just giving you the introduction to the term. So it determines if a system or a product protects the data. It handles with a lot of data, like banks means our account data that is sensitive and private to us, username, password, and so on. And does it maintain security related functionality as it was intended to be. Security testing involves further realities, confidentiality, integrity, and availability. What does confidentiality say? As the word indicates, it's a requirement, it tests for requirement that data and processes set up by a software or a system is protected from unauthorized disclosure. I get my bank information provided I have specified the credentials correctly. I get my system marks online provided it is me, I have provided the username and password correctly. That is confidentiality. Integrity is tests for requirement that data and processes be protected from unauthorized modification. Somebody manages to get access to my data, person is unauthorized to access my data, then the person continues to be unauthorized to modify my data, because that is even bigger than accessing the data. That is integrity testing. The next one is availability testing. It tests that data and processes be protected from denial of service to authorized users. Means if a particular person is authorized to have access to a particular data or a service, then the data or the service is made available to user. So that is what is availability testing. So security testing tests for confidentiality, integrity, availability. It also deals with authorization and authentication validation. Authorization, to give you an example, typically you might say that if something is available in the private mode, then only the person who owns it is authorized to view it, but something is made public, then everybody is authorized to view it. So it gives permissions to say who is authorized to view, access, read or write to a certain content. Authentication is the process of validating a particular user. There are authorization policies like role-based authorization, MAC, DAC and so on that are popular across systems software provided by several different products, and typically security testing involves validating for authorization and authentication policies also. So the various types of security testing will test for the following. It will verify that only authorized accesses to the system are permitted. It will also verify that the encryption and decryption algorithms that are used for encoding data or messages work correctly. It also verifies that illegal reading of files to which a particular user is not authorized is actually not allowed. It ensures that if you have an antivirus software, they actually prevent, far from preventing, they also curtail entry of viruses into the system. Typically, security testing, also testing tools and techniques also identify what are called backdoors in the system. Backdoors in the system refer to classical coding mistakes that developers could make, which provide illegal access to an unauthorized user or a hacker. One of the backdoors is buffer overflow, which hackers are supposedly said to use to hack into a system. So security testing also systematically works towards identifying such backdoors and ensures that access through these backdoors is actually not possible. As I told you, it verifies for authentication, authorization, and there are several protocols at various layers that these security policies use based on what their communication interface is. They could use several wireless security protocols, client-server security protocols, authentication protocols. Each of them has to be separately tested at appropriate different layers. Security testing covers for all of them also. Next is reliability. The term reliability indicates that the system is reliable in the sense that if it runs for really long time, continues to perform, doesn't degrade. Let's say I buy a particular electrical appliance. What does it mean for an electrical appliance to be reliable? Let's say if I buy a fan, when I mean it to be reliable, I expect it to work for many years without failing. That's what I mean for a system to be reliable. So what does reliability testing do? It is a test to measure the ability of a system or a software to keep operating over a specific period of time. The specific period of time is usually long, measured in terms of years or sometimes months. Reliability includes hardware reliability and software reliability. It involves different techniques. Both of them deploy a lot of probability theory and statistics, which we haven't covered in this course. So there's a separate area that you can run a separate course on. There's that much of information and literature available. So the next in our list of non-functional system level testing would be scalability tests. What does it do? It says, will the system scale? In the sense that, let's say, a particular server or an online web software, let's say HDFC Bank Online, is supposed to cater to 100,000 simultaneous users logging in and accessing their respective account information. Another classical example is our Indian Railways booking website, right? Is it scalable? The normal road could be several thousand users. During Tatkal, it could peak at a higher number. Does it cater to the maximum number of users that it is supposed to cater to? Can it scale up to its limits? The limits need not be only in terms of users. It could be in terms of any engineering parameter that we specify. For example, one is the number of users, the other is the size of the database that it can manipulate. Like, for example, if you take an Aadhaar system, right? Aadhaar system should be scalable to cater to our country's population. So that is its engineering limit, right? So scalability testing involves testing the limit of a system. That is, it is the magnitude of demand that can be placed on the system as it continues to perform in the sense that it has a committed response time. No matter if there are 10 users logged into the Indian Railways ticket booking website, or if there are 100 users or 1000 users logging into Indian Railways ticket booking website, it still meets its commitment of booking tickets upon availability within a specified time. So that is what scalability testing does. So what could be the causes that can limit a system from not being scalable? Typically, the typical major causes that prevents a system from being scalable are the data storage could be limited, the sense of accessing the database and actually storing the data. It's a very big problem actually to be able to store data in such a way that it doesn't get heated up, especially for large systems like Facebook and WhatsApp and all. Data storage is a huge problem, or even Google and things like that. The other big problem that could limit scalability is network bandwidth. It could be less, it should work, it should switch over to a non-GUI graphics, plain HTML kind of thing. Next limiting factor could be the speed limit. By speed limit, I actually here mean the CPU speed, the processor speed. So scalability tests, actually what they do is that it's very difficult to create a use case for a maximum number of users. Let's say a system says it can cater to up to 500,000 users. It's very difficult to actually write a test case that will create a scenario of 500,000 users logging to a system and accessing data. Such kind of test cases are very expensive to create. So what they do is that they create test cases to the extent that they can, and then they extrapolate the basic data and test the system for scalability. That's how scalability testing works. So it again needs a lot of statistics. So the next kind of non-functional system testing that was there in our list is documentation testing. So basically, whenever you have a software or a product or a system, it comes with several documentations, like a user manual, which could be an online manual or a printed manual. It could have tutorial, it could have an online help. A lot of these kind of things are there. So they constitute what is called the documentation of a software, apart from the actual code also being documented. So documentation testing is basically checking if all this documentation is correctly done to the extent that it is supposed to be. So it is done to verify the technical accuracy, it's correct or wrong technically, and the readability. Is it readable? Is it understandable of the various documentations? Such kind of documentation includes user manuals, tutorials, online help, and so on. Documentation testing is usually performed at 3 different levels. The first level is what is called a read test. Basically, somebody competent in the area, sits and reads the documentation. In that process, the documentation is reviewed for clarity, for organization, in the sense the contents, are they laid out correctly? Chapter is organized properly, sections are organized properly, the flow and the accuracy. This is just static documentation testing. Nothing is executed. Then there is something called hands-on documentation testing, where And online help is actually exercised by a user, like a dummy login is created, and then they go as if they don't know anything, look for online help, see if it provides the right kind of help, see if it provides the right kind of error messages, and then they sit and evaluate how useful it is, how accurate it is. Then there's something called functional documentation test, which basically checks if the instructions that are given in the documentation are followed and verifies that the system works as it is supposed to be. It meets its functionality as documented. So some of the tests that people usually do while doing documentation testing are as follows. Somebody, as I told you, manually reads through all the documentation to check if the grammar is correct, there are no typographical errors, technical terms have been consistently used, and so on. Somebody reviews the use of graphics, images, like for example, typically, let's say you're buying a product like a car, then there could be several views of a car. In certain view, you can see certain parts of a car. So is the graphics giving the correct view of a car, correct view of the cross section of a car, of the front of a car, of the chassis of a car, and so on. That's what people check for graphics and images. Then somebody actually verifies the glossary of terms that accompany the documentation, and somebody verifies that there is a proper indexing of terms that is available as a part of the user manual. Every index you typically see there'll be a term and a page number where the term appears. So they go and manually check if the page numbers have been correctly generated. Most documentation generated software can do this automatically, and the scope for error is less because it's automatically done. But people typically still go and check this as a part of their routine documentation checks. Then they go and verify that if you have a printed version and an online version of a user manual, they are actually one and the same. They are not different. They don't differ from each other. Then they verify if the specified installation procedure is actually working correct by executing the steps on the actual system. Then they verify the troubleshooting guide with the actual scenarios. So this is all, it's quite exhaustive. They do a lot of exhaustive documentation testing, and it's a pretty non-trivial, non-functional testing. So the next in our list is regulatory testing. What do we mean by regulatory testing? If you had bought a toy, typically you would see that it has these words called CE printed in a little sans serif style. So that stands for Conformity European. Sometimes you would see FCC, CSA. These days you see FSSAI in food products. So these are all regulatory standards that describe or tell you that a particular product, including software operating on a system, is of a certain quality. So to be able to get that kind of regulatory assessment passed, usually software and system developers have to specifically undertake a testing called regulatory testing. They basically insist that you do a huge amount of documentation and perform routine tests as mandated by the corresponding regulatory authority. In addition to this, if you have safety critical systems, like for example the drive-by-wire, brake-by-wire, steer-by-wire, or the power window controller in a car, the ABS system, the airbag system, or let's say autopilot of an aeroplane, the landing system of an aeroplane. These are safety critical because if they fail, then they mean huge losses in terms of loss of life. So safety critical systems have to go through extra regulatory requirements. I had told you about this on and off in my lectures about this particular standards called DO standards for avionics. Similarly, for automotive, there is IEC 61508, MISRA guidelines, and so on. In fact, latest you might have heard of this Google and Tesla's driverless cars. So they have even stricter regulatory standard. So basically, people do regulatory testing to cater to a particular standardization based on the domain of applicability of the software and the system. So now we finally get into performance testing. So what does performance testing do? It is testing done to determine if the system parameters in terms of responsiveness and stability work fine under various workloads. So performance testing measures the performance of a system for several different quality attributes. Typically, it performs it for scalability, reliability, resource usage, and a few others that we will see very soon. So for example, here is a typical example of how a performance testing requirement could be. A transaction in a particular online system requires a response of less than 1 second 90% of the time. So what does it say? It says that the system will respond fast enough. How fast? In less than 1 second. And not always, not very little, but most of the time. That most is perfectly quantified. It says 90% of the time. So this is a typical example requirement of performance. So when I performance test for this requirement, I create data that helps me to validate whether this requirement is met or not. So typical performance testing techniques are classified as follows. These are the most popular ones, but again, they are not exhaustive. There are some more that I have not listed in these slides. Load testing is a performance testing technique. What does it do? It's in fact the simplest performance testing technique that is conducted to understand how a system behaves under a certain load. Like I told you, right? If I have IRCTC system, a peak load, let's say for such a system occurs during Tatkal booking hours, then load testing checks if the system actually caters to that peak load. It will result in measuring important business critical transactions, load on the database, application server, and so on. Stress testing is another kind of performance testing. It is performed to find the upper limit capacity of the system and also to determine how the system will perform if its average current load goes well above the expected maximum. Let's say there's a particular system, let's say a system that displays the marks or the results of a higher secondary school examination. You can imagine that the system will be very stressed for the first few hours after the results are out, right? So what they do is that, let's say it is supposed to cater to 100,000 students accessing their marks soon after the results are out. When they stress test it, they will test it for a limit above 100,000 to see how the system actually responds to it. They'll stress the system in terms of giving inputs to the system and see if the system is able to cater to it, or if it fails, how exactly does it fail. The next kind of performance testing is what is called soak testing, also known as endurance testing. This is performed to determine system parameters under continuous expected load. So you understand the meaning of the word soak, right? Soak means what? I keep it soaked. I see how there's a steady load that comes in continuously of a standard number of users periodically without a break. Does the system perform as it's expected to? So that's what soak test does. Typically, it is useful for how much memory is utilized and whether there are memory leaks or not. Then there's something called spike testing, which is a kind of stress testing. So spike testing is like stress testing, but what it does is that it increases the number of users suddenly. There's a sudden spike, not a gradual spike, and see how well the system performs under this sudden increase in the number of users. The increase in the number of users need not be above the maximum number, but it's a fairly sudden increase. So the main aim is to determine whether the system will be able to retain the sudden increase in the workload. So I have covered only 4, but there are several other performance tests, as I told you, which I haven't really not mentioned or covered here. So for performance testing, typically it's important to know what is it that you're going to measure. What are your goals? What is it, the data that I want to capture? What am I going to measure? Because if you go all over the place, there are so many parameters you can capture, so much data you can capture. Typically as a tester, you'll be left with an overdose of information, with too much of data that cannot be analyzed. So it's important to find out what is the kind of performance testing that one is going to do, currently doing. And for this kind of performance testing, what is the precise goals I have? What is the set of data that I want to measure to be able to achieve these goals? So typically there are 3 kinds of performance testing goals that people can have. You could take a single system and demonstrate that the system meets its specified performance criteria. You could compare 2 different systems of the same kind and determine which performs better than the other with reference to a specified set of criteria. Or you could identify and measure the parts of a system or workload that cause a system to perform badly, the violating parameters. You could focus on that. So typically whatever you do, performance tests will include one of these or most of these parameters. Let's say most of the systems are meant to interact with users. So it will say how many number of concurrent or parallel users are using a system. That's one of the things. Then what is the throughput or transaction rate that the system is committing to, and what is the server response time. In addition to these three, any other specific measures that you want to include can be included. So here are some performance testing tools that are very popular. Some of them are proprietary, some of them are open source. I have marked those that are open source against the tools. The rest of them are proprietary. The most popular performance testing tool in my opinion is that by HP. It's called Load Runner. Before I move on, what do these kinds of tests do? They basically generate scripts for execution. They generate large number of performance scripts based on your target of performance measurement, and they also execute these scripts. That's the purpose of these tools. The popular one is by HP, Load Runner, been there for many years. There's one more tool called NeoLoad, which is useful for web and mobile applications performance testing. There's a tool called JMeter, which is good for web applications. This is an open source tool. There's another tool called Rational Performance Tester, again a proprietary tool. There's a tool called Gatling, which is again good for web applications and open source. If you recap my lectures on web applications, I had given you a link to another web applications online testing tool. That page is an exhaustive listing and includes several other performance testing tools also. Here I have just put some of the ones, in particular HP Load Runner and JMeter I have tried out. The rest I've heard others using it, so I thought I'll put this list. So typically after these performance testing tools generate and execute the scripts, you might have decided on the parameters that you want to monitor, like the ones that are mentioned here. So how do you monitor these parameters? You actually hook the system to external things. You separately run offloaded scripts or drivers that will monitor the system, or even hardware devices that are plugged in to monitor these parameters. They are monitored, as I told you, with the help of special dedicated scripts that don't run as a part of the main system but run separately, so that the performance of the main system is not affected. Or they could even be monitored with the help of external devices that are hooked to the system in which the test scripts are running. So that was a brief overview of performance testing and non-functional testing. I'll go back to the slide that I began with, the taxonomy slide. We did cover an overview of all of these. I'll do one separate lecture on regression testing. It also helps to know what I didn't do before we end this module on non-functional system testing. So we didn't look at usability testing at all. Very important, very significant area. There's a separate testing for graphical user interface. Again, extensive algorithms based testing is available based on finite state machines and so on. We haven't looked at any of those. And as I've told you 2-3 times by now, we haven't at all looked at security and reliability testing in detail. So it is to be noted that there's a fair amount of material available in all these areas, and there's active research still going on, but we've not been able to cover them in the course. So I'll end here and I'll come back with a module on regression testing. Thank you.